Hi, this video will show you the basics of how inductors work, why they're so useful, and we will discuss some applications for them. Whenever current passes through a wire, a magnetic field is generated. Now, it doesn't matter how much current or what type of wire or anything like that, whenever current flows, a field is generated. When sending current through a single wire, however, the field generated is quite small but not insignificant. But if you take that same wire and wind it into a coil, then the magnetic field generated is much greater. This is the basic principle of an inductor. They are simply coiled wire, often with cores. Additionally, creating this field is quite intense, so initially, when an inductor is first connected to a supply, its resistance is very high. This resistance then drops as the field builds, until it's almost negligible. This means that as a general rule, inductors do not like a change in current and take time to adjust. Let's look at a circuit to make this clearer. This circuit has a 10 volt DC supply connected with a switch to turn it on and off, as well as a large inductor, a bulb in parallel, and a resistor. Now, if I play the simulation and toggle the switch, you'll see initially the bulb lights up. This is because initially the resistance of the bulb is much lower than the resistance of the inductor, so the bulb gets the majority of the current. As the inductor generates its magnetic field and gets used to the new current, its resistance drops and the bulb, now without much current, goes dim. If I then disconnect the switch, watch what happens. Remember, inductors don't like changes in current. The inductor, now with no current from the supply, collapses its magnetic field and discharges it into the lamp, as that's the only place it can go. This is done in an attempt to maintain the current, until eventually the inductor's field has completely collapsed and current ceases to flow. In this way, you can think of inductors as devices which store power in their magnetic fields. So we know that inductors don't like changes in current. This means when an inductor is connected to a constant DC supply, once it is charged, it will allow current to flow freely. Let's look at what happens when you connect an inductor to an AC supply. In this circuit, we have an inductor and bulb in series with an AC supply at 10 volts. If I simulate the circuit, you can see the current going through the inductor seems to be making a sine wave, so it seems to be allowing the AC to pass. However, if you look carefully up here, you can see there's only a few hundred microamps. The inductor is only actually allowing a tiny amount of current. In this way, you'll often hear inductors referred to as AC blocks. So in summary, inductors allow DC to pass through, but they take a while to adjust initially, and they block AC from passing through at all. In this way, inductors work similarly to capacitors, only inverted. If you'd like to know more about capacitors, then there is a link below. Capacitors allow AC, but block DC. This means that knowing how to use both capacitors and inductors is absolutely essential. This AC blocking feature makes inductors great at blocking surge currents. This is where a short burst of current is created. In this case, the inductor will be protecting another component from being damaged. Inductors are also used in switch mode power supplies to temporarily store charge, then discharge it. I will cover these supplies in a future video. Thanks for watching. I upload a new video at least once a week. Be sure to like the video if you liked it, subscribe if you loved it, and have a good day. See ya!